USPAP Standard 1 clearly states that an appraiser must be aware of, understand, and correctly employ those recognized methods and techniques that are necessary to produce a credible appraisal. But it does not state what those recognized methods are. But all professions have a body of knowledge. The body of knowledge of the appraisal profession includes the 15th edition of the Appraisal of Real Estate. Here we see a list of adjustment techniques to use in the sales grid: paired data analysis, commonly called paired sales, grouped data analysis, secondary data analysis, statistical analysis, and depreciated cost analysis. Solomon has calculators for all these techniques, but for this presentation, we learn only the basic principles behind depreciated cost analysis. Where do we get the term depreciated cost? This is from page 3 of the 1004 form. Depreciated cost is simply the market value, the contributory value of the improvements. If the indicated value by the cost approach is $300,000, the site value is $65,000, and the as-is value of the site improvements is $10,000, then the value of the house is $225,000. Depreciated cost is the market value, the contributory value of the improvements. Notice that the cost new of the building is $250,000. However, when the market pays only $225,000, then there must be $25,000 of depreciation. The depreciated cost, the contributory value of the improvements, is $225,000. In other words, the market pays 90% of current cost. The 1004 and other appraisal forms all assume economic age-life depreciation. Economic age-life depreciation calculations involve 3 variables and 1 assumption. The assumption is the number of years of economic life. Because Solomon licenses cost data from National Building Cost, we'll begin with the economic age assumption National Building Cost makes in developing its cost data. Notice how economic life is related to quality. Structures of the highest quality have a 70-year economic life. However, the lowest quality has a lifespan of only 55 years. From authoritative sources, let's look at some important and necessary definitions on depreciating cost. Economic life means the building's total economic life, which begins when the house is built. It ends when the house no longer contributes to its designed use, thus is no longer the highest and best use of the underlying site. This period is typically shorter than the house's physical life expectancy. Remaining economic life is the estimated period over which the house is expected to contribute economically to the overall property. It's an estimate of the number of years remaining in the economic life of a structure or structural components as of the effective date of the appraisal. Appraisers use it in the economic age-life method of estimating depreciation. Think about this definition of effective age before you estimate it on page 1 of the 1004 form. In applying the concepts of economic life, effective age, and remaining economic life expectancy, appraisers consider all elements of depreciation in one calculation. Therefore, the effective age estimate includes not only physical wear and tear, but also any loss in value for the functional and external considerations. Let's apply this to some depreciated cost adjustments. Remember our cost approach example that showed the market paying 90% of cost? Here's how to develop a bath adjustment. Per our source of third-party, unbiased cost data, the cost of a bath at the time of construction, but not adding a bath to an existing house, is $12,000. Using the same cost data, we saw there was 10% depreciation. So, if the market is paying 90% of cost, we have support for an adjustment of $10,800. This is support, not proof, since there is no such thing as a proven adjustment. This is just a recognized technique of developing a market market-based adjustment. It's market-based because, as we saw, the market is paying 90% of cost. A bathroom is an example of a unit adjustment. This same thinking applies to a fireplace. Things do get a bit more complicated, however, when we consider components that have square foot costs. Take a garage, for example. A two-stall garage of 440 square feet costs $43.40 per square foot, or $19,136. If the market is currently paying 90% of cost, an adjustment for no garage compared to a two-stall garage is $17,222. A one-stall garage of 220 square feet has a higher cost per square foot, but a lower total cost. The adjustment for no garage compared to a one-stall garage is $10,329. The adjustment from one garage stall to two garage stalls is $6,893. Before we get to a GLA adjustment using depreciated cost, let's look at a scatter plot using sales data to find a GLA adjustment. Here we see the sales price on the y-axis, the vertical axis, and the GLA on the x-axis, the horizontal axis. For good reason, as you can see, statisticians call this a scatter plot. Differences in variables other than the amount of GLA are what caused the data points to scatter. As you can see, one of these sales has very expensive lake frontage. There's a wide range of site values, of condition, and of quality. Some have one-stall garages, while others have three stalls, plus a porch and a fireplace. This statistical analysis of sales prices shows that only about 27% of change in price is due solely to changes in GLA. In other words, this statistical analysis did not tell us much. With our depreciated data, however, we can do much better than that. Here are the cost data we license from National Building Cost. This happens to be from 2021, and which we update yearly. This is cost new, so there are no differences in the effective condition. By focusing on Q4, there is no effective quality. There are no site value differences. Because in this analysis we examine GLA cost only, it's isolated from other features such as garages, basements, and porches. This is pure GLA cost from $153.15 per square foot for a 700 square foot house down to $99.87 per square foot for a 5,000 square foot house. Let's analyze these data by looking at a total cost rather than just a cost per square foot. Here are the data arranged in columns. The 700 square foot house has a total cost of $107,205. But watch what happens when the program extends the calculation down through the whole table. This is set up for a scatter plot, but there is not much to scatter. In fact, 99.9% of change in the total cost of GLA is due to a change in the square footage of GLA. The equation, which is the regression line, tells us the story. Total cost of any dwelling is therefore about $91 per square foot times the number of square feet plus $46,700. Up on the right, we have the economic life at 60 years because that assumption is baked into the cost data. If the improvements are effectively 30 years old, then remaining economic life must be 30 years. 60 years minus 30 years effective age leaves 30 years remaining life. Depreciation is 50% because 30 years of effective age is 50% of the 60-year total economic life. In other words, for a property such as this one, the market is willing to pay 50% of cost new. The market is paying approximately $46 per square foot because one more foot has a cost new of approximately $91 per square foot. If the improvements are effectively 15 years old, the remaining economic life must therefore be 45 years. Depreciation is 25%. The market, therefore, is paying 75%. The adjustment rate is $69 because $69 is 75% of $91. Now for a final thought. In this last example, remaining economic life is 75% of total economic life. If you know the remaining economic life, if you have extracted it from the market in the cost approach, then you know the percentage of costs the market is currently willing to pay. The contributory value of the improvements is 75% of their cost new. This works in the grid because the sales comparison approach is all about the contributory value of one more square foot, one more bath, one more garage stall, and so on. Solomon does all the math for you, not only in calculating the grid adjustments, but also in assigning results such as effective age, which is a statement of fact you must support. Don't think this is true? See the comment to Standard Rule 1-3B in USPAP. In addition to its expertise in depreciated cost, Solomon does market time adjustments, secondary data, sensitivity analyses, and forecast analyses. Want to know more? Send Scott an email. Schedule a Zoom demo with Scott at a time that fits your schedule. Scott loves talking with appraisers.